Good day. This I can like do physics today. Physics is very simple subject, but many people don't understand the concepts. I've planned it that SS1, SS3. I want to give you general things that every physics student need to know. Fundamental quantities and units. Quantity. What's fundamental? Basic. Base unit. That is, it doesn't depend on any unit. It's independent of its own. We have length, meter, this is the spelling, and it's represented by M. Mass, kilogram, is represented by kg. Time, second. I think you can see everything. Temperature, Kelvin, electric current, ampere. So, but what matter most is the derived quantities, which means all the quantity we'll be driving now here will fall with based on this because they are independent, but all other quantities depend on this for survival. Now, quantity unit, I think you have known this now. Now, let's quickly discuss derived quantities now. Derived quantity, derived quantity, derived derived quantities. So now uh, it's very important for WAEC, NECO, JAM, or post JAM because they will take your ability of the unit. So if you want to derive any quantity, you must know the formula. Very important. Then now substitute the value. For instance, now let's start with the simplest one. We have area. Everybody knows that length multiplied by the breadth. Breadth. Then uh, we know that the unit of length is meter. But there's one thing you need to know. Breadth, height, distance, displacement, displacement, the unit is meter. What that means that anywhere you see the breadth, the height, distance, displacement, the unit is what? Meter. Like now, length is meter, it means that times another meter. We have the word meter square. Volume is length times breadth times height, which is meter multiplied by meter multiplied by meter, which is equal to meter raised to power 3. Then, I told you that you have to know the formula. That's why maths and physics they go pari passu. You must understand mathematics before you can excel in physics. Now, velocity now is equal to displacement over time. Time taken. From this place now, you know that displacement is meter. You can see it, meter, and our time from fundamental quantities is what? Seconds. That's meter over seconds. But in physics, they don't usually use meter over seconds. They use what? Meter per seconds, which means you have to do meter per, you write like this or like this in some textbooks. So meter per seconds, that's the unit of velocity. Then we have acceleration. Acceleration, we are not dividing here, it's just velocity over time. Velocity over time. You can see now that velocity has been derived already, which is meter per seconds. You have it here, meter per seconds over seconds. But we want to bring these x together, these seconds together. It's either this one come here or this one goes there. Now, if this one come down from indices, that's why this is very important. This one will become meter over x plus s1 plus 1. That is a meter per second square. If this one goes there, this one is plus a. If it come here, it will become meter minus 1 minus 1. That's meter per second square. Which means the right unit of acceleration is a meter per second square. Now, force. Everybody knows force. Force is the popular unit is Newton. Newton represented by what? Capital N. Capital N. But in questions, you may not see Newtons as option, especially WAEC or JAM or post JAM. So they want to test your knowledge of drive units. Force is mass multiplied by acceleration. Acceleration. That is formula. You know, I told you that to drive any unit, you have to know the formula. Mass. The unit, parameter unit for mass is kilogram. Acceleration, we have already derived it, which is a meter per second square. Multiply everything, our answer will be kilogram meter per second square. That is the right unit of what? Acceleration, which is the same thing as what? Newton. Newton here. Then we can also have um, work, energy. Work, energy. So work is force multiplied by distance. Distance. It means that, you know, this one is n. This one could be n times m. It could be Newton meter. Then, or in place of force here, place this, which means you have kilogram meter per second square times meter. Meter times meter, that's kilogram meter square per second square. Which means this is a unit of work. And don't forget that the well-known unit of work is joule. Joule, name of man being like you, joule, which means joule is the same as Newton meter and also the same as a kilogram meter per second meter square per second square. All this one is the same thing. Joule is same as Newton meter. What is the same as kilogram meter square per second square. Now, this is work. Unit of energy is also joule. Unit of couple is also joule. Let me write this for you. Moment is joule. Work, work has the same unit as energy, has the same unit as moment, has the same unit as couple. Now, I know some of you will ask me that which type of energy, because we have many forms of energy. We have heat energy, electrical energy, mechanical energy, and so on and so forth. But energy is energy, they have the same unit. For instance, uh, you know, this is joule energy. From mechanical energy, we have two. We have kinetic energy, which is half mv squared. We have potential energy, which is mgh. M here means mass, v here means velocity, g here means acceleration due to gravity, h means height. Now, what we want to know if it's equal to joule, if it's equal to joule or kilogram meter square per second square. Our mass is kilogram. Forget about half. Our mass is kilogram, which is kg, and our v is velocity is a meter per seconds square. You can see that law of indices, this one will be kilogram meter square per second square, which is same as what? Joule. If you try this also, we have potential energy, mass is kilogram, this one is acceleration due to gravity, which is same as meter per second square. A is meter. You can see that that's meters square per second square. So it's the same thing. Even if we have electrical energy or heat energy, heat energy is Q or MC theta. We want to check if this one will be equal to joule. And don't forget that mass is kilogram, and this one is specific heat capacity. C means specific heat capacity, and unit of this one is joule per kilogram per Kelvin. Joule per kilogram per Kelvin. Now, this heat energy, we have it to be, which is Q. We want to know if it is equal to joule. Our mass is kilogram. Specific capacity is joule per kilogram per Kelvin, and this is temperature, which also is times Kelvin. You can see that law of indices, this one is 1 minus 0 because we have kg times kg minus 1 times joule times k 1. This one is 1. This one also is 1. From the law of indices, because they have the same base, kilogram, kilogram. That's kilogram 1 minus 1 times joule times kilogram minus 1 plus 1. This one is kg raised per 0 times j times k raised per 0. Law of indices. N raised per 0 is 1, which means q will be equal to 1 times j times 1. That is the unit is joule. You can see now that any energy you use, joule is still the unit, or kilogram meter per seconds, meter square per second square. Even you can also use electrical energy. You can use electrical energy. When you use electrical energy is IVT. Electrical energy is IVT. This one means current, this is volt, and this is time. And you can see that current is Q over T. Q over T. That is a coulomb per seconds. Coulomb per seconds. And for voltage is joule per coulomb. Joule per coulomb. This one means joule per coulomb times seconds. You can see that our energy is equal to, just like what we did here, we have C raised by 1 times C minus 1 times X minus 1 times X times 2. That is C 1 minus 1 times X, because this 1 minus 1 plus 1 times 2. This one is C raised by 0 times S by 0 times 2. So which means 1 times 1 times 2. Which you can see that now that joule has many quantities that is unit for it. Work, energy, moment, couple, electrical energy, potential energy, mechanical energy, they are all have the same unit. They all have the same unit. Now let's go to power. Let's go to power. Let's go to power. Power, the first thing you need to know is the units, the formula before you prove the units. Because if you don't know the formula in your medulla oblongata, so because power now, the general is what energy or work or work over time, which means the general one we know is watts. Because watts, unit of power is watts. But power could be, work is joule over seconds, which means power could be what? Joule per seconds. Power could also be, joule is also Newton meter over seconds. That is a Newton meter second square. So then power could also be kilogram meter square per second square over seconds. When you do just to see, you have kilogram, meter square per. This one become minus a. That will be kilogram meter square x 3. You can see now that unit of power alone is watts, joule per seconds, Newton meter per seconds. Also, we have kilogram, meter square, and so on and so forth. So that's it on the drive unit. You can drive any unit provided you know the formula. So you have to read very well and have your formula in your head because anything can be answered, asked from you. So continue to follow me, AI mathematics and AI physics. Follow me, like me, and share me. Thanks for watching me.